But today we're working on doing it with substitution. Again. So what is required in order to use substitution? You need a variable isolated. You need a variable to be by itself. So when I look here, do I have a variable isolated?
Yes.
Yeah, in the bottom equation, I know y equals 5x minus 4. So I could take this and plug it in for y in the other equation. That would leave me with 5x minus y. So I have to subtract all of y. So it's going to be minus, in parentheses, 5x minus 4, close parentheses, equals negative 4. Huh? Well, I've not done anything yet but substituted. You do have to. So there's an understood negative 1 out here that I have to distribute to both terms. So this would be 5x minus 5x plus 4 equals negative 4. Now, do I have any like terms?
Yes.
I do. 5x minus 5x, those combine to be 0x, which is 0. So I'm left with 4 equals negative 4. So when all the variables go away and cancel out, I'm left with just a math statement. Does 4 equal negative 4?
No.
That's nonsense. That's not true. Therefore, there is no solution. So graphically, what would these two lines look like? They would be parallel lines that never intersect. That's what gives a no solution answer. Okay, so if we're using substitution, we need a variable isolated. So right here's my variable that's been isolated. Is everybody good with that?
Yeah.
Plugging that in?
Yeah.
Okay, well let's see. So x plus negative x plus 5 equals negative 4.
Yeah.
Well, you could distribute this positive 1. So that's just a negative x and a positive 5.
That's all
Yeah.
right. And
I
I just
got
put
that.
5 equals negative 4.
Do I have any like terms?
I made that a 6 because there's a 1.
Because that
It's multiplying.
I distributed the x.
Because 1 minus 1 is 0.
Yep, so this is 0.
So it's 5 equals
So I'm left
negative
with
4.
5 equals negative 4,
That's what I got.
which is a math statement because there's no x's. It's nonsense.
No solution.
So
What?
the next one's 5 is 5.
Yeah, that's what I got.
I don't have what does. Sometimes it doesn't do.
You know. I got
I
you another.
actually put some more.
I know, it's funny. So,
Yes, sir. Thought I had some.
So the mistakes we made, just so I can make sure that I know to talk about them if I need to. You guys, when you did 1 times 5, you put 6. One of you did that?
Which one?
You did 1 times 5 was 6. And what did you do differently?
I distributed the x instead of positive 1.
Yeah, I
So I
did.
said, I just put negative 1x plus 5 instead of x minus x.
I said it's catching.
B, do I have an isolated variable?
Yes.
I do, right here. Y equals negative 2x plus 5. So plug that in for y. So now I've got 2x plus negative 2x plus 5 equals 5. And I could distribute this positive 1. So 2x minus 2x plus 5 equals 5. 2x minus 2x cancels, goes to 0. I'm left with 5 equals 5. which is a true math statement,
Infinitely many.
infinitely many.